Hi, and welcome back to another video on object-oriented programming using C Sharp. And the topic for today is encapsulation. Encapsulation is one of the pillars of object-oriented programming. Have you ever wondered how to secure your data in C Sharp and make the code more clean and reliable and maintainable? The answer is encapsulation. By the end of this video, you will understand encapsulation in C Sharp inside out with real-world examples and a step-by-step explanation. So what to expect from this video? We will look at what is encapsulation, how it works in C Sharp with some real-world examples. We will also dive into best practices and some real-world scenarios that will help us to understand it in a better way. Let's get started. At its core, encapsulation is all about hiding the internal details of a class and restricting direct access to certain components. Think of it like a black box. You don't need to know how everything inside works, but you can interact with it in a controlled way. Breaking down the diagram, this diagram represents a class which contains data and methods, also known as variables and functions. Data 1 is private, and private here is an access modifier. This means it cannot be accessed directly from outside the class. It's hidden for security and to prevent unintended modification, thus ensuring the integrity of the state of the class remains intact. Data 2 is public. This one can be accessed from outside, meaning other parts of the program can use it freely. Similarly, the methods. Method 1 is private. Only the class itself can use this method. It's hidden for external access. Method 2 is public. This means the method can be called from outside the class, allowing controlled interaction with the object's state. We will look at this and understand it better. Think of a car. We can start and drive a car without knowing how internally the engine works, without having to worry about the internal details or exact functionalities of how the engine actually works. That's exactly what we do with access modifiers. We use public access modifier to give a well-defined controlled access to the outside world of how the functionality can be consumed. When I say controlled access with proper validation to ensure that the data what is coming in is valid and the internal state of the class stays valid. So let's look at different access modifiers. We have public, private, protected internal, and private protected. Coming to public, it is a no restriction access modifier, be it same class, derived class, same assembly, or any other assembly. It is accessible from everywhere. So that is the accessibility for public. Uh, any other class or methods anywhere within the application, within the same assembly or a different assembly, has the visibility when you use this access modifier, which is public. Use case when you want to make the member globally accessible. That is when we use a public access modifier. Coming to the next one, that is private, the most restrictive access modifier, which means that it's available only within the contained class or struct. So the visibility is only within the same class. That's exactly when we use a private access modifier. It's used to encapsulate the data and implement internal logic, which is strictly within the class. Coming to the next one, which is protected, accessible within the containing class and by the derived class. So it is accessible within the same class and the derived class, not accessible for same assembly. And in case of other assemblies, if there is a class which derives a protected class, it's still a derived class, so it'll be able to access. Coming to the next one, which is internal. Internal is limited to the current assembly, so it is accessible within the current assembly. It's accessible to the same class, derived class, and any other class within the same assembly, but not accessible anywhere outside the assembly or not accessible to any other assembly. So the use case for this would be allow access for types or members only within the same project. That would be the use case of a internal access modifier. Coming to the next one, which is protected internal. A combination of protected and internal is what is protected internal access modifier. So, which means that anywhere within the same assembly or a derived class outside the assembly, it's accessible within the same class, the derived class within the same assembly, and also outside, also accessible from a different assembly if it is a derived class. We need to keep in mind, be it protected or protected internal, for other assemblies, it's only available for the derived class. That's the point to be remembered. The next one is private protected. This was added in C Sharp 7.2 and above. More restrictive combination. This is one step. We call this one step above the previous protected internal. So, more restrictive combination of private and protected, which means it's available within the same assembly and in a derived class, but only within the same assembly. That's where the private kicks in. So that's why we call it as private and protected, strictly within the same assembly. Jumping into an example without encapsulation, what is the problem it causes, and how to fix it with another example by applying encapsulation. Bank account class has a balance field. Any user can modify balance directly, leading to invalid values like negative balance. This breaks the rule of the system and compromises data integrity. So now, if we run this example code, we can see that the program class was able to modify the balance to minus 1000, which is a data integrity issue. And since we don't have encapsulation applied in the bank account class, it allows it to be modified. Now let's see how we fix this. Now let's look at an example with encapsulation applied. Balance is now controlled using private access modifier, wherein it is not available for direct access, ensuring data integrity. We have public methods exposed to give a controlled access to balance. Private modifier protects the balance from direct modification. Public methods deposit and get balance, allow controlled access, prevents negative balance issues, thus ensuring data integrity. So, by using access modifiers this way, we ensure the public endpoints are used to give a controlled access to the internal state of the class. Now, when we try to run this example, we see that when we give a minus 1000, which is an invalid state, it ensures that the integrity of the internal state is maintained and it doesn't allows a minus value to be updated to the balance, thus ensuring the data integrity. Now let us see how to make use of properties for encapsulation. Instead of using separate get and set methods, C# provides properties for simplified encapsulation. As we can see in this example, we have a field balance, which is private, which is actually the state which holds the balance. And we have a public double balance, which is a property which is exposed for public usage. And if we notice, only the get part is public. Internally, the set is made private. The set part, which actually writes the value to the field, is made private. And even when it is private, we have code which implements data validation to ensure that the balance stays valid. Now, we have exposed a public deposit method using which the external system communicates with the bank account class. And deposit method in turn makes use of this property, which is a private set, to set the balance. This way, By using a property, we can implement encapsulation and making it private to set, and also implement a validation to ensure that the internal state stays valid. Now let us also look into how we can make use of read-only properties to secure the data, and also how we can make use of write-only properties. We have an example of a student class here with a public constructor, which takes in name and roll number at the point of object creation. And we have two properties, name and roll number, which are public as well, but we have get implemented and we haven't implemented set. By not implementing the set, we can keep the properties public because they can only be read, they cannot be set, thus ensuring these values are always set at the point of object creation. And by directly accessing name and roll number, we can only read them and we cannot set them. So thus, by using read-only properties, we ensure that direct access to name and roll number is only for reading purpose and can't be used for assigning a value. Now let's have a look at write-only properties. We have a password manager class which has a public password property exposed, which has a setter. We haven't implemented a getter because we don't want to allow the user to read the password. We have a setter implemented using which we can assign the password, which in turn uses the hash password method to hash the password before it assigns it to the password hash private property, thus ensuring that the public endpoint property, which is password, can be used only to write and cannot be used to read the password, thus ensuring, be it accidentally or intentionally, the password is never read, thus ensuring that it is safe. So we can make use of write-only properties in this way to ensure that anything we would not like to expose out, but we would like to accept the value. Thank you for watching our video, and do subscribe our channel for more such videos, and thank you very much for your support.